Hello, we are the Carcass Rocket Design Team, and we are here to present our rocket, the Galileo 02. So this rocket was created to compete at the half-kilometer apogee category, but with the simulations that we've run with RockSim and Open Rocket, we got an average apogee of 478 meters. It has a total mass of 2.65 kilograms, with a center of gravity located at 61.3 centimeters from the tip of the nose cone, and right behind it, we have the center of pressure at 71.7 centimeters. That gives us a static margin of 1.89 kilograms. The propulsion system is made out of a H motor class with an average thrust of 301.1 newtons. The thrust time is 0.903 seconds, so that gives us the total impulse of 271.8 newton seconds. And it has a mass of 511 grams. So the propulsion system is made out of the bulkhead, case, nozzle, propellant ring, and a inhibitor / an insulator. It has a total length of 226.5 millimeters and a total diameter of 38 millimeters. The bulkhead, the case, and the nozzle are going to be made out of 1020 size steel. The propellant is KNSU with 65% of the oxygen and 35% of the fuel. The thermal isolant and inhibitor is going to be made out of fiberglass and epoxy resin. The maximum chamber pressure is going to be 6.98 megapascal, and the burn time is 0.867 seconds. The recovery system is going to be composed out of an ejector and the parachute. The ejector is going to be pyrotechnic, and it's going to have a piston that is equipped with a firebolt and the opposite corner of the cylinder that has an igniter and crimson powder that we have chosen over black powder because it has a lower temperature combustion that is going to minimize any heat damage that may occur to the rocket or the parachute. So the pressure is going to drive the piston, ejecting the nose cone and the parachute, starting the recovery system. The deployment is going to happen at the apogee, and it was designed to have a terminal velocity of 8 meters per second. So the parachute is going to be made out of nylon ripstop with a diameter of 68.9 centimeters, and the diameter of the spill hole is going to be 13.71 centimeters.
The onboard avionics system will contain two Atmega 328P, one as the main system and the other used exclusively for the recovery system apogee detection and Kalman filter calculations. For the subsystems, we have an onboard storage subsystem that uses an SD to locally store data for further analysis and service as a black box. The telemetry subsystem, we use two NRF 24L01 with a range of 1 kilometer. One will be on ground and the other will be on board of the rocket, allowing communication between those 2 points. Each one of these components will have their own energy sources. Recovery subsystems, we use an MPU 6050 together with a BMP 280 to detect an apogee based on hydro. This subsystem applies a Kalman filter to avoid erroneous readings. There will also be a redundant system for the recovery system in case something goes wrong, and a GPS allowing the ground team to locate the rocket after the flight is done.
The total length of the rocket is 103 centimeters, and it has an outside diameter of 5.5 centimeters. As said before, the total mass is 2.65 kilograms. The materials used in the rocket is going to be ABS filament for the nose cone and some internal tubes. The both tubes are going to be made out of fiberglass. We have wood fins, and the motor support is going to be nylon.